Did you know that the Earth has two North Poles? True north is the direction to the geographic North Pole, which is equivalent to the Earth's axis of rotation. And the magnetic North Pole, indicated here, is the direction to the magnetic North Pole. This is a point on the surface of Earth's northern hemisphere at which the planet's magnetic field points vertically downward, which you can see here. So this is Earth's magnetic field, and at the magnetic North Pole, it points downward. We also see the same phenomenon in the southern hemisphere. So there's both a geographic South Pole, which is the axis of rotation, and a magnetic South Pole, which is where we see vertical orientation of Earth's magnetic field. So in addition to the scale bar, which we saw in the last section, all maps must include an indication of direction. And this usually comes in the form of a north arrow or a compass rose. A complete reference will include true north, magnetic north, and grid north, as well as the angles between them. So grid north is the direction of a coordinate grid system overlain onto a map, just like the reference systems that we looked at in the last section. Grid north varies from true north because there is no perfect way to project around Earth onto a flat map. So this creates a bit of error. But in most cases, grid north is going to be fairly close to true north. As I said earlier, if a north arrow is missing from a map, it's probably safe to assume that the sides of the map are aligned with true north. So in this case, you can see that this side of the map is probably aligned north-south, and the text will be way up. So we can assume that the top of the map is north. When we navigate using a map, it's relative to true north, the axis of rotation. But when we're hiking or sailing, we often use a compass that points to magnetic north. In order to follow our intended route relative to true north, we need to account for the difference in angle between true north and magnetic north. And this angle is called the magnetic declination. You can set magnetic declination on a compass so that you are actually following a path relative to true north. Importantly, the amount of magnetic declination varies relative to your position on the surface of the Earth. So be sure to change this when you try navigating in a new place. There's an added layer of complication as well. Earth's magnetic poles actually migrate over time. So before you head out on an adventure, check the date of publication of your map. If you're using an older map, get on the internet and check the magnetic declination for today for the area that you're going so that you don't get lost.